I'm Joey Pickardt, German audio engineer and guitar player, and you're watching Building Up a Modern Metal Tube Amplifier. We've reached the point where the amp makes sounds, clean is working nice, crunchy sounds are coming out of the preamp for the lead section, and today it's finally the time where we can hear real high gain tones out of the amplifier. So I promise you at the end we will hear the mostly complete circuit, and we will have a overview over all the details, where is what in the circuit and how does the signal flow go through the actual amplifier. And after that we are going a nice and understandable bias procedure on that amp, and after that I tell maybe something about the power measurement of the amp. So if that sounds interesting for you, stay tuned and let's get started with the rest of the build-up. Okay, and we start where we have left last video. So you can see at the corner, at the left corner down there is 2, now are 5 yellow capacitors. This is the first stages of the preamp. We have left the last video with 2 preamp stages operating, and now you can see how I am adding the third triode of the preamp. This triode will operate for lead and clean channel muddy mode, so I'm adding 2 capacitors for just one triode stage to get out different coupling values from the anode of the third triode, so I can have different sounds for the muddy mode and the lead channel, but you can hear it in a second, I think. Okay, I've installed the third triode, so the clean channel should now have the selectable change between clean and muddy, I call it, where I switch between 2 and 3 triodes of the preamp, and the lead channel has just the third triode of its sound, and I connected both to the masters of the channels again. Okay, let's see if it works. At first I'm going to measure the voltages on the plates. Hopefully everything is correctly and nothing goes down in smoke. Preheat is on since 2 minutes, and I now engage the high voltage. Okay, no smoke. Good sign, I believe. Let's see, first I change to voltage, DC voltage, and then we will look. Third plate. $330 volts. The main power supply voltage is 354, so we have a pretty low current drop. That's at this triode understandable, because I'm using a very high resistance for biasing the triode, 33K, like in Mesa, Soldano and PV5150, just to try out if the sound is that I'm searching for. Okay, let's have a quick look at the biasing voltage. And they have it 3.75. Okay, then let's have a look if we have a sound. Okay, nothing. It's a pretty easy failure because nothing is connected. Okay. Clean channel. Ah, we've got sound. Nice. There should not be a big change because this is a clean channel. I take the 2 triodes and get off there. Okay, the switch does something, my reverb tells me. Oh, I hear something. and I hear a lot of more gain. Reverb off. Nice. I think the cameras are distorting now, but I enjoy the volume. A lot of gain from the clean channel. Yeah, let's have a look what the lead channel is doing. Reverb off. Compare both channels. Okay, I don't know if you can hear that, but I changed between two capacitors at the output of the third triode, so I'm using 1 nanofarad for output for lead channel and 22 nanofarads for output on clean channel. This is because I have 2 more stages to drive, 2 more triodes to drive in the lead channel, and I filter out a bit of the bass. So that the highly distorted sound is not getting too muddy and swampy. But I don't know if the 1 nanofarad is the right choice. Maybe it's too less. At the moment it sounds pretty nosy, pretty high midded, too less bass. So the clean channel is sounding good so far, and that's what I want, because the clean channel is going out there. There's no more drive at it, and I'm going to the equalizer from there in the signal chain. The lead channel is awaiting a lot of more triodes and a lot of more distortion, so I wait until I've finished all of that before I decide to take a bigger capacitor or not. Nice, now I'm working only on the lead channel section for the 4th triode, and this is also where I add the function of the noise gate. The noise gate is attached to the amplifying circuit. I also finished the 4th triode of the lead channel, and the modern and vintage switch is working. And now we're going to find out how it sounds and if the gate is working with the modifications I've done. We can hear a lot of noise. Amp is working. Vintage 12 o'clock gain. Of course on bridge pickup as a humbucker with both coils. Yeah, modern is more aggressive, is working. Vintage. but we can hear the noise. Now I engage the gate. Okay, no noise, but no guitar, pretty quiet. Now I go up with the gate. Ah, there it comes. But it is working. Okay. Pretty close. Longer. This is nice. Okay, still too close. There we go. Okay, I added a resistor, so I have to do this one smaller, so I'm in the sweet spot up here maybe. But this is working. Okay, I also have an equalizer here to add more noise in the boost, like everyone is doing with Tube Screamer or something like this. This one, mid boost, 9-10 decibels, and very noisy without the gate. I engage the gate, no noise. Nice, grungy, raw. And off. I have to say I was pretty happy when I could hear the first metal tunes out of the amplifier with that rich and open distortion and not a compressed and dump distortion. So I think this is the right way that I've told. And imagine what happens if we add 2 more stages, which I am installing right now in the video. I am not adding that much gain on the top of that, but I'm shaping the sound finally, and I'm putting on an anode follower. The 6th triode is an anode follower that is pushing the equalizer much more, and then we can operate with more filtering in and out frequencies, because this is a stronger way to do an equalizer. Okay, the gain stages are all engaged now for the lead channel. No equalizing is finished, but the pure tone of the preamp is finished from build up. Maybe I do some tweaks on it, but I show you the sound of it right now without any equalization. I have the noise gate engaged and go down with the gain. Pretty nice, huh? I've just recorded that with my smartphone, so I didn't use a decent mic setup at the 2x12 cabinet that I was playing. The 2x12 cabinet, this one over here, is built after a Mesa oversized rectifier box 2x12, and it is loaded with vintage 30s, of course, not the Mesas, but English Celestials. And so you have a reference. But I'm promising when I have finished the complete circuit, you can see it right now, I'm adding some parts in the equalizing section. When I finished that, I will do a complete playthrough with a nice microphone setup here, like you would expect it from a good amp video. Okay, the complete circuit is finished and we are going to have a quick overview, but at first have a look at this nice clean front panel. It's much better and professional looking than the hand drawn that I've done before for orientation. Also, the back panel is in the same design. And now it's looking like a real amplifier, I think. The logo is an homage on the big amplifier builder that I like the most. It's a Boogie, and I think it's looking real nice. Okay, and now let's have a dive into the complete circuit and where everything sits, starting with the power supply. We can see here over on the right, this is for the heaters, the DC heater, the 6.3 volts. Then the small diodes here are for the high voltages. So I'm at this point I'm having around 430 volts. This circuit here is for the biasing, and this FT capacitor over here without values on the top, because I've worked a lot in here and the values are gone by laying my hand here, so I've written it on it, is the third capacitor in the power supply high voltage path. And down here you can see the JJ capacitor with the two 100 microfarad taps before or for the anode power transformer middle tap, output transformer middle tap, and the second B pluses for the gate 2 of the power amp. Okay, then over here in the middle we have the power supply, the power amp. You can see up there the both sockets and where my crocodile clamps are connected, because we are going to measure the bias in a second. And over here we have two capacitors that are feeding the signal from the phase inverter into the power amp, and a bit of bias correction and gate grid stoppers, and the two potentiometers where we can adjust the bias. Over here is a small rectifier with a capacitor for a second low voltage signal pass or delivering pass for the noise gate. So I'm just generating around 7.3 to 7.5 volts for the low voltage noise gate circuit, which is down under there behind this this capacitor, the red one. Okay, on this board also there is a part of the power supply. This is the very last and second last stage of the power supply filtering for the very first preamp, and it makes sense to get it over here so it is nearby the input and by the input tubes, so you can't get a lot of noise into the supplying voltage path. If I had placed it over here, I have a much longer way where I can collect noises and feed them into my circuit and amplify them a lot, and then I have a noisy amp. So the close as you can get to the very first preamps is better for less noise in the high gain section. Okay, then over here we have this pre-configured effect loop board with high voltage MOSFET transistors. It works, but I don't like it a lot. So I'm totally building a second amp, and there I'm going to use a real tube for effect loop because it's not much more in price. It's a bit more work, but then it's a truly completed tube circuit. Okay, let's get into the very first stages. So here is the input, and at this side we have it over here. So this is the input jack. There's a resistor. When you don't connect anything to it against ground, that the amp is quiet. And this wire here is feeding the signal from our plug into the first triode stage with two resistors, once against ground, this one, and once against the gate for a grid blocking resistor. And this goes on and on and on over 6 triodes until here. And we have a look at the complete preamp. The preamp ends over here at this capacitor. You can see 1, 2, 3, 4, 5, 6, 7 capacitors, yellow ones, and a bit of blue smaller electrolytic capacitors. The yellow ones are always at the anodes to delivering the signal, but not the DC anode voltage to the next stage. And the capacitors, the electrolytic capacitors, are the cathode capacitors, the bypass capacitors for the cathode, always connected parallel with a resistor, like here. You can see it here, over here. It's nice to see. Okay. So the signal jumps now between those capacitors, the triodes, and the signal pass, and sometimes I do a little of signal shaping with the small disc capacitors parallel to resistor or connected to ground to filter out some high frequencies or bypass a bit more high frequencies. And I've tried different capacitors to get the perfect noise shape that I wanted for the high gain channel. And you can see I'm taking always at the complete preamp shielded cables, like here. So I'm always going out and directly in a shielded cable. Also over here where the channel switching is, at the side mounted, you can see the 6 connected cables are all shielded. So I'm getting, for example, here, over here, to A1 to A3. A1 is the input signal from the first gain stage, and A2 and A3 are getting the are going to the preamp regulators for clean and lead channel. It's just an example. I think these are the return way, and down over there, here's a second relay. Down over here are six signal wires also, and there is the input connected, not really here. I think this is the return, so return channel 1, channel 2, and output for the effect loop. Okay. And then we have this bit left, starting over here at this capacitor. This is the last capacitor that is going out of the cathode of the last triode in the preamp of the lead channel. So this is a cathode follower, and is fed into the equalization circuit and the volume regulation of the lead channel over here. So you can see this wire is going to be connected somewhere What's the wrong one? It's going right over here. Just up into the presence. Okay, and then we have this little fella here. This is an optocoupler, and it is connected to the channel switching, so that I'm muting this circuit over a resistor against ground with this optocoupler when I switch channel, so that there is not noise and maybe a bit of overspeeching signal from my lead channel feed it into the clean channel, so that I have a very nice clean channel without any low noise distortion over talk. Okay, this is the first optocoupler, and under this resistor we have a second optocoupler, and this one is for operating the noise gate. So this one is closing the channel at the point of the lead master channel. So here's a signal channel, a signal wire connected, and under this capacitor is going to the second optocoupler, and this is performing the muting when the noise gate is active. So this optocoupler is driven by this yellow and blue wire from the noise gate. So the absolute output of the master of the lead channel is muted against ground if the noise gate is closing. Okay, then it's a few left. This part here is for presence regulation and feedback from the power amp output. So this wire is connected to the output transformer and to the 8 ohm output of the transformer, and is fed back into the circuit at the phase inverter and connected to one of the presence regulators, so that I can play around with a bit feedback presence style, and in the other channel there is a not feedbacked presence control. Okay, and this both fellas here plus the few resistors is the phase inverter. So where the signal is split into two signals to feed it back into the power amp where we started a moment ago. And this is it. Some last infos or views. These are the fuses at the very first points for the heaters and the high voltage. Before I use the voltage somewhere in the amplifier, these are the reverb regulators plus the switch where I can choose the solo boost. And the solo boost function is done with this relay, which is placed over the noise gate. So we can't see the noise gate, but you can see here the capacitor and the resistors that are damping the signal and shaping the signal for soloing. Okay, this is the complete overview, and now we can start biasing the amp and measuring the output power and have a look at some signal flows. The first thing that I do is, let's switch over to this camera, bias the amp. The amp is biased, but I do it with you together because I promised it. My camera failed the last time, the first time that I built up the amp. So we are doing the biasing now, calculate the plate dissipation of both power amp tubes, and after that we are feeding a signal into the amp and calculate the output power that the amp is delivering RMS. First, I have to connect the 230 volts, and I'm starting the standby so the heaters can warm up the tubes. And while this is happening, I show you the signal path that is done. I'm using this Focusrite audio interface and feeding the headphone output signal, so this fellow over here, into my effect loop return. So it's only the power amp and the master volume connected at this time. It's all for power measurement, not for biasing at this moment, okay? Then the amplifier with only the master volume is working, is amplifying the signal, and this one here is the output of the 16 ohm speaker connectors, and it's running into this NUX Solid Studio. This NUX Solid Studio is just used to get my audio signal back into my audio interface without directly connecting to the speaker output and load. It's not activated, it's just for getting out the signal into my interface back. And then over here we have this 150 watt 15 ohm resistor, where we are going to lay the output signal of the transformer on instead of a speaker, because it would get pretty loud. So it's a quiet and nice way. You can hear me better, I think. Okay, but at first we are doing the bias measurement, so I disconnect the signal input, and we have only the amp running on a load and nothing more. Okay. I have this both crocodile clips. They are connected against the 1 ohm resistor, which is connected between the cathode of the power tubes and ground. So, and if you have a 1 ohm resistor, you can easily take the value of the measured voltage and set it for the current that is flowing through the circuit, because 1 ohm multiplied with X amp is X volts. 1 multiplied with something is 1. Ohm's law. Okay. My multimeter is connected with 1 wire against ground and is measuring the voltage. And at first I'm measuring the bias voltage of the tube V6. And master volume is turned down, and I can supply the high voltage now. Okay, here we go. Don't know if everyone can see it. I'm taking this camera. 0.031 volts. If I would like to change it, I could use this potentiometer and change the value to higher or lower current, but as I said, the amp is finally biased and this is a good value. So this is the same in voltage or in milliamps or amps. So we have 32 milliamps. The same for the 7th tube in my amp, and you can see I've done a good job. We have also 32 millivolts or milliamperes, and to prove that I'm not doing something wrong here, this is the right potentiometer and I'm on the right tube. Perfect. 32 millivolts. Now we have to draw that value down. I do it in a second, but at first we have to measure the high voltage, and I think I have to move my amp a bit. Yeah, okay, so you can see the display. And now it's one hand in the pocket and one hand in the amp, and we measure of the left tube the high voltage. You can see it. I'll move it over here. Same thing always. Okay, 360 79 volts. And over here, the other, I am expecting the same value. When I get connection. $379 volts. Perfect. Now I turn off the amp. Okay, leave it on standby. And we can take those values. We have 3, 2 milliamps and 32 milliamps here. Our anode voltage is 379 voltage at both. So we have the absolute same plate dissipation. So the wattage that is produced and converted into heat, while the amp is not operating within signal, just the clean operating biasing point, the working point of the tube. And this is, when we take a calculator over here, just Ohm's law, so we have to multiply just this value with this, and 397 multiplied with 0.032 is 12.7 watts for both tubes. Okay, typically a lot of amplifier just have one bias adjustment, and you have to find the sweet spot. In this operation way, I can get both at the exact same plate dissipation. It is nice if you don't matched tubes, you can get them at the same operating point, but tubes that are way away from each other will sound different even if you put them on the same working point. So I'm always taking selected tubes, matched pairs, and then getting the last squeeze out of it with this both regulators. Perfect. Okay, that's all for today. I hope you had fun watching and could learn something, or you had an own idea for building up an amplifier. I hope you are interested in the next videos where we finally can hear the amp in a real setup, so you can get an own opportunity if I have done a good job, or maybe in the next video you can tell me what you have done other than me. And I'm pretty interested in that one, because this discussion is going to be interesting, because you can tell me what your preferences are, and maybe I have some thing in mind that we could change on that amp to get in this or that direction. I'm also adding in the next video a measurement setup through the complete amp, so this is going to be pretty interesting because I haven't seen that much on YouTube, and we are going definitely to have a look at the equalizing section, so where the frequencies are dialing in and are operating with each other, and we are going to have a look at the signal shape of the clean and the lead channel, and how the distortion is formed and the signal is looking like when it is sounding like in the last video, for example. So if that sounds good, hit the like button, maybe subscribe, and I see you next time. Bye!